This lesson is going to start our unit about understanding area, all things area. Today, the goal is to start with basic area concepts, and then we're also going to use that to find the area of rectangles and what we call composite figures. The goal of today is that it should not feel new. My hope is you have seen area before. We're going to cover the basic concepts to make sure that we're on the same page and extend it further. So the big idea behind area is what we've done before with measurements is we've started with what we call a linear unit. A linear unit can be defined as any sort of length, but let's say I call this my one linear unit made up of a line segment. And with this linear unit, this could be 1 centimeter, 1 inch, 1 mile. The idea where area comes from is if I take this linear unit and if I extend it and I form a square out of it, and each one of these sides has a length of 1 linear unit, then area is thought of the space inside of this square. So I would say this square is 1 square unit big. We take this idea of square units and we take them into figures, and this overall idea of area is just counting up the square units inside of figures. Some are easier to count than others. The easiest ones to count would be a rectangle or a square because we can simply count the number of squares. So with the rectangle shown, we have all of these squares, and if we start counting, the first row has 1, 2, 3, 4, 5, 6 squares. The next row has 1, 2, 3, 4, 5, 6 more. That brings us up to 12. 1, 2, 3, 4, 5, 6 more brings us up to 18. So that gives us a total of 18 square units. But if you notice, every time I counted, there was 6 squares, and we did that a total of 3 rows. And so I could have gotten up to 18 by taking my 3 rows and multiplying them by the 6 squares per rows, which takes us up to 18 again. This idea of rows by columns, that takes us to rectangles, where obviously we don't want to break a rectangle into a bunch of little squares and count them every time, especially if there's a lot of squares. And so we can take this idea and translate this that the 3 times 6 was like taking a length and a width and multiplying them. So the area of a rectangle is either the length of the base times the length of the height or the length times the width. This is our formula for a rectangle. So it does not necessarily matter which one we call length or width. So let's say I called the bottom the length and this part the width. And let's say that we call this 4 units long. This is 3 units long. Then the computation is simple from here. The area of my rectangle is 3 times 4, which is 12. Whoopsies. It is 12 units squared. To get in the habit of remembering units, you could either write this as u squared or you can write it as square unit. Either way is showing us that we know that this is area, and so now the units are squared rather than the linear, which does not have a square. Extending this further, if I have a square, we can think about it as a rectangle where, as we know, all the sides are equal. So taking this idea of length times width, if I just call each side length S, well, with area being length times width, that makes our area side times side, which comes out to be side squared. And we can use this as a quick, simple calculation that the area of a square is equal to side squared. These are 2 basic formulas for today. Area of a rectangle is base times height. Area of a square is side squared. As we move forward from here, we have a couple of postulates that are going to guide what we do here. The first postulate is this idea that if a region is closed, if it doesn't have any openings, it has an area. It might not always be easy to calculate, but it does have an area. The next postulate is that if 2 closed figures are what we say congruent to each other, then we know every pair of sides are congruent, every pair of corresponding angles are congruent, perimeters are congruent. We've looked at all this before, and we can also extend this today to know that their areas are going to be equal. So if 2 figures are congruent, they will have equal areas. The last postulate that's going to help us out today and with our work with area is this idea that if I have a region that is not familiar, it's composed of a bunch of different shapes, and these closed regions intersect along a common boundary. So down here, this is our common boundary for this 5-sided figure here, 1, and this figure here that has 4 sides, if I separated them, there is no overlap. So we can say that the area of their union, when I put them together, is equal to the sum of their individual areas. So the area of figure 1, let's say I could figure that out algebraically, will be equal to the area of figure 2. I'm going to check real quick to make sure that everything's working. We're good to go. All right, let's keep going. All right, so next up, we're going to look at a couple of examples. This figure right here does not look, this kind of like Z figure does not look like specifically what we're used to finding, a rectangle or a square. This is what we would call a composite figure. We've made a different shape out of composing figures we know more about. The idea here being that if I wanted to find the area, we can separate this and we can break it apart and find the area of smaller pieces, and I call this method the divide and conquer method. First part, if I were to extend this segment to this point, I have now cut the top part into a rectangle. I could do the same thing on the bottom. If I connect here, I have connected it into another longer rectangle with this little square figure on the inside. Now, you have some choice here, how you choose to divide and conquer. I could have also, maybe you noticed, drawing downwards and create two shapes here and here, whichever way works for you. I'm going to stick with this way. So now what we want to do from here is we want to figure out the area of the different rectangles. So now I have rectangle 1. My goal would be to find its area. I have rectangle 2, and I have rectangle 3. So at this point, for my top rectangle, its width is 5, its length is 12. I have all the information that I need. So I can do length times width to get its area to be 60 square units. For the bottom rectangle, all the way across, its width is 18, its height is 4. I can figure out that its area is 18 times 4, which is 72. So the area of my bottom rectangle is 72. Now here's the challenge. When I get to the middle, I am missing measurements. I need to know what its width is. I need to know what its length is. If I look at the top, I know that this section is 12, but the problem didn't tell me how long this piece was, so I can't use that to find the green segment. So let's go to the bottom. They told me that the whole long bottom section was 18, and then I know the portion is 14. So subtracting, we can figure out that this piece here has to be 4 units long. Next up, using this idea of a rectangle, I know that the top 2 lengths, the 5 and the side across from it, would have to be congruent, making this piece here 5 units long. So from the segment that is 9, if one piece of it is 5, we can reasonably conclude that 9 minus 5 is 4. The other piece would have to be 4. So now we have our measurements. Area is length times width. That makes the area of figure 2 come out to be 16 units long. So now, using divide and conquer method, we have 3 different pieces. So that makes for us here, the area would be 60 plus 16 plus 72. We add the 3 pieces together, and when we add those up, that gives us an area of 148 units squared, and that is our final answer. All right. We're going to go ahead and we are going to look at example number 2. We're going to look at the area of a square. With example number 2 here, the big thing to remember is that the area of a square, we want to know what we're heading towards to find what information we need. The area is side squared, so that feels pretty simple. All I need to know is the side. Did they tell us the side? Well, let's see. They gave us the diagonal. Okay, so we need to figure out what to do with that. Let's first start and visualize. If I draw this square, if I draw on its diagonal, I know that the diagonal length is 20. Since it's a square, I know that I have right angles at the corner. And then I know that my different sides will come out to each, let's call them S. So if each side here is S, and we're looking for this, a couple things I noticed is that I could set up Pythagorean theorem to find the length of the sides. But let's also think about maybe a simpler method that we have. I want you to remember that if I have a rectangle, and if I have a square and I divide it along the diagonal, it cuts my angles in half, and this is 45 degrees, and this one is 45 degrees, making this a 45, 45, 90 triangle. So if my two sides are S and S, the third side is what we call S square root 2. So remember that the three sides are x, x, and x root 2, and we'll just replace the x with an s in this case. So that means that s times root 2 equals 20. So now to solve here, I have to divide by root 2. So that makes our side equal to 20 divided by root 2. Remember now, we need to multiply by the square root of 2 over the square root of 2, our special one. And this gives us 20 root 2 over 2. And then lastly, we can reduce to make that 10 square root 2. So we know that our side now is 10 square root 2, but remember, we're not done. We were asked to find the area. So now I know that the area is equal to side squared. So this would be 10 square root 2 squared. Remember, when we square something with a root, we square the number, so 10 squared, and then we square the root. So that makes this 100 times 2, which gives us an area of 200. So this square with a diagonal length of 20, the side is 10 root 2, and the area is 200 square units, or 200 units squared. If at this point you feel like you are understanding, you get the basics, and you're ready, go on to problem set number 1. There's 5 questions there. If you would like to see another multi-step problem, including area of rectangles that goes a little bit beyond the basic application, let's move on to number 3, and I will work this through here. So next up in number 3, we are asked to find the area of a rectangle with perimeter of 28 and a diagonal length of 10. The interesting thing to note here is they didn't tell us what either the length or the width is. So when we go to try to apply our formula, the area is length times width, we don't have either piece. So let's see what we can do. If I draw in the diagonal length, I know that this diagonal is 10. I know I have right angles, but I don't know that the diagonal bisects the angle like we did before. I know that my perimeter comes out to be 28. So if I label my different sides, if I say that the two pieces on the left and the right are the length, and the top and the bottom sections are the width, let's see what we can do with this. If the perimeter is 28, I can at least make an equation with these two variables, that 2 times the length plus 2 times the width is equal to 28. Something that I notice here is these are all multiples of 2. So I could divide by 2, and that makes that the length plus the width is equal to 14. So that seems helpful here. I at least know that the two pieces, they have to come out to be 14. Now, at this point, there are 2 different routes that we can take it. One will be a little shorter, one will be a little bit longer, and each one just depends on what you notice, so I'm going to do both. The shorter route is you could do guess and check from here. It has to make a right triangle. So if you think of if the numbers were whole numbers, they would be Pythagorean triples. So you could ask yourself, is there a Pythagorean triple with the hypotenuse of 10 where the legs add to 14? Here's what I think of. The 3, 4, 5 triangle multiplied by 2 is a 6, 8, 10 triangle. So it's a 6, 8, 10. That gives us what we want. That gives us a hypotenuse of 10, and the 2 legs would be 6 and 8. Well, quick check here. 6 plus 8 is equal to 14. So this is a right triangle, which we need, but it does have legs that add up to 14. So this gives us here that our legs will come out to be 6 and 8. Let's say you didn't notice that. Let's say you didn't think about it, or you want to be absolutely sure that your guess was correct. We can always, with 2 variables, see if we can set up another equation. Here's what I notice. I've already used length and the width in the perimeter formula, but I also have the Pythagorean theorem. Because it's a right triangle, I know that the length squared L squared plus W squared is equal to 10 squared. If that's the case, if L squared plus W squared equals 10 squared, that means for us here that I could use substitution and replace in my equation. So that means that, let's say I want to substitute for L. L is 14 minus W, and that means that 14 minus W squared plus W squared equals 100. From here, I'm going to pause for a second. The rest of the solving of this is algebra. If you still don't feel comfortable with solving out a squared equation all the way through, I will complete this. But if you are tracking up to this point and like to move on, let's pause, finish the question, and then we'll come back. To finish the question, they ask us to find the area. It will come out that the length and the width are 6 and 8. It doesn't matter which one is which, but we know that one will be 6, one will be 8. So that makes the area come out to be 6 times 8, which makes the area 48. So the answer to this problem is 48 square units for a rectangle that has a perimeter of 28 and a diagonal of 10. At this point, if you feel like you understand, you can move forward, you can work on the problem set. Now I'm going to finish this all the way through. So let's go back down to our system. When we square this out, remember that we have to do our formula. So the first number squared is 196. Then we multiply the two numbers together and we double them. That makes minus 28W. Then we square the last term, plus W squared. And then we add on the plus W squared equals 100. Looking here, these are not opposite signs. They do not cancel, which means we will have to factor. So if I rearrange, this gives us 2W squared minus 28W. Now, I'm going to subtract the 100, add it to the 196. This gives plus 96 is equal to 0. Now, before I factor, if there's a 2 in front, we might just have to deal with it, but let's check. Everything is a multiple of 2, so let's divide by 2 to make it a little bit easier on ourselves. And this gives us the W squared minus 14W plus 96 divided by 2 is 48. And now we ask, what multiplies to 48 that adds to negative 14? When you run through the list, it ends up that W could be negative 6 or negative 8. So that makes W equal to 6 or 8. Now in this case, both of those are positive. None of them are bigger than 14. They both work. So what that means is that if W was 6, L would have to be 8. Or if W was 8, L would have to be 6. Either way, we go back up to our pair. That gives us our final answer of 48. And this is the end of day 1, 11.1, understanding area. Next up is the problem set. Complete those 5 problems and you are done for the day.